If you notice that the first term is a perfect square and the second term is a perfect square, and you have a negative here, we can actually say that it's actually the difference of two squares. What we want to do with this is we want to apply the shortcut that we actually learned in factoring trinomials, that video 2, to where you take the c and find factors of that to actually equal your b. So what we're going to do is we're going to write equivalent statements that mean exactly the same thing. It doesn't change the quantity, it just changes the way it looks a little bit. So it's a little bit easier to work with and see our solution coming along. So what I'm going to do is I'm just going to put down x squared and then plus this placeholder 0x, because obviously there's no x's in or terms with just a regular x in there within this equation. So I have x squared plus 0x minus 16. So notice this is still equivalent to what we started off with, and now applying the shortcut, all we have to do is look for factors of negative 16 that add together to be 0. And those two factors are a positive 4 and a negative 4. And of course, if you were to add them together, you would get 0. So those are our two numbers. And so, using the shortcut method, all we have to do is just put our parentheses, our two sets of parentheses, and put in our x's in the beginning and plug in the 4 and the negative 4. And we're done. So you can do this with any of them, just as long as you know that you do have a perfect square as the first term, and a perfect square for the second term, and a negative in between. This only works for the difference of squares, not the sum of squares. That's a whole different ball game. That's actually prime. So I hope this helped in factoring the difference of two squares.